Alrighty, again we're Math 115. We are doing linear regression, exercise SP18, part 1. That's found in our resources. I guess I should mention that this linear regression is in our resources as well, under linear regression, I believe, for the formulas on how to figure out how to get the B and the A and the R values. For the R value, we're going to be working, in this video, we're going to work on the R value. These are the two formulas. We've got the really long formula that's very complicated, and then we've got the easier formula, which I would say we should really focus more on the easier formula. He said, according on the test, he doesn't care which formula you use. That's going to be up to you. He's just going to say, get me the R value. But I'm going to do both for these videos because he taught it to us in class. And he did tell us that the R is, basically the meaning of R is the correlation coefficient, meaning that somehow it's connected. One thing we need to know is that R is always a negative between -1 and 1. I don't know if we're going to need to know this, but he did say that R squared is the coefficient of the determinant. Let me see if I can go over any of the other notes that were important. Okay, here. The R equals 0.90 in the positive, right? It says that 90%, it means that 90% of the variation of the dependent variable is explained by the variation of the independent variable. I guess that's the best way to describe it. And 90%, that 0.90 means that 90% of the variation of the dependent variable, which in our case would be the weight, is explained by the variation of the independent variable, which would be the age. And it doesn't matter whether it's a positive 90 or negative 90, they basically mean the same thing. Another thing that we want to know is, not that one, we covered that, is that B value is equal to the slope, meaning that, say, like the 0 is the value of x, or A for us, and when crossing the y-axis. It's the value of x when crossing the y-axis. So it equals the y-intercept. And that's why we would be getting that B value. I think that's pretty much it. Let's just try to jump into this then. Okay. So we're going to focus first on doing the simple, the simplest R formula. Okay, so we've got the R equals B times standard deviation for X and the standard deviation for Y. Okay, so what is the B? Again, we figured out the B in the last video, and it is 1.14, and I'm just going to stop with 0.2. And then we're going to times that by the standard deviation for X. And let's go ahead and take a look at what the standard deviation for X is. For us, it's going to be A, right? So the independent variable is taking that place. So A, what is the standard deviation? It's 4.453266. Let's go over two of the ways that we find that standard deviation. First way, we can just type in STDEV. This is on Excel, right? We could do it this way, which is the simpler way, and just say, hey, what's the standard deviation for all these in A? And okay, that's the easier way. The way he taught us with the formula would be right here, and that was the A minus A mean squared, right? We would need the sum of that, sum of all of that divided by the count. What is the count? The count is 20, and it was like n minus 1, right? Divided by n minus 1, which is 20 minus 1, which would be 19. That would give us the variance. That's the variance. And then we would say, okay, what's the square root of that variance? And say, what's the square root of that? Okay, Those are the two ways we can get the standard deviation. So we would have to get the standard deviation for the age and the weight, which would be our x and the y. Okay, so our standard deviation is 4.45. And let's just say 4.45 divided by the standard deviation for the weight, which is 18.06. 18.06. And so we would divide this number by that number, then we would times it by this number, and then that would be our answer, and that would be that, whatever the answer would be, that. Well, let's do that on the calculator just because don't want to confuse everybody. All right, so we're going to take that 4.45 divided by 18.06, and I just took two decimals, right? And it's 0.246, times it by b, which is 1.1402, and that would give us our r would be 0.280946, and continuing on, right? Okay, so simpler way to do that on Excel, the simplest way. All right, let's see how we can do this. Okay, again, so we're gonna take the b. There's our b. Oh, let me take it from this side. Our b. It's exactly the same thing, but oh. And then we're gonna put that times button, and we're going to put in parentheses, we're gonna take the standard deviation for the age, and we're going to divide it by the standard deviation of the weight, and we're going to close that off. Now, you can't just put that parentheses without putting that times button, because otherwise it's going to calculate it wrong. Yeah, so that is the simplest way to get the r, right? You take the b value and you times it by the standard deviation of your independent variable divided by your dependent variable. And you're going to do that for all the rest. But here is our complicated way of doing things, and that's where we have to find the numerator and the denominator and the product, and the individual variable denominator and dependent variable denominator, and that's where we're doing this really long thing. Okay, so let's start with this. We've got the count. What is the count? We're gonna do this by paper first before we do it by computer. Okay, so what's the count? The count is 20. Okay, so we got 20 times the sum of xy. Okay, so we did the xy area, right? Xy here, which is our age times our weight, our independent times our dependent variable. We had times each one of these, and then we added it all up. So what is the total? The total is 103,819.25. Okay, so that 20 times this number, and then it says we need to minus the sum, right? Got that sigma, the sum of x. What is the sum of x? Well, let's take a look. We've got basically the x is that a, right? Our independent variable. What is the sum? It's 552. 552. And we're going to times it by the, it says sum of y, which is the w, which is 3746. Okay, so we've got that all written out, right? We've got that all together. So let's figure out what this is. We are going to take out our calculator, and I'm going to do the 552 times the Oh, geez, I just messed that up. 552 times 3746. And that is going to come out to 2067792. And let's take that 20 times this number here. We're gonna go 20 times 103,819.25. And we've got this number here, 2076385, and we're minusing that. So let's find out what that would be when I minus this number. So we got that number minus 2067792. We got 8593. Okay, so we know our numerator is going to be 8593, right? So that top line here, all of that was just to find out our numerator. Now we're going to work on the bottom. The bottom, let's start with everything. This is the square, right? We're going to the square root of all of this that's in here. Okay, so let's start with the bottom. We got n. N we know is 20 in this case. Times the sum of x squared, which is x squared again is our independent variable, which is a, and we had done that already. We had already figured out we had summed up each one of the ages squared, then we summed it all up. So we got the sum of 15612, right? 15,612. So I've got that, right? 15,612. Then it says we have to minus it from the sum of x with the sum of x, and then square that sum. Okay, so this one is not the same as this. This is not just each one squared and summed up. This is sum up all of the ages and then square it. So 552 squared, which I'm just going to use the computer for that. Right? And we've got 304704. Okay, you got that? Okay, so that's in this bracket. Oh, that's together. This bracket. So the next bracket right here, which we're going to be timesing the two answers by. Let's start that. Let's write it a little smaller. The count. And it's going to be times the y squared. Let's go ahead and look at that. All the sums of y squared. So again, this one means that we took each of the the dependent variables. We squared each of the dependent variables, and then we added it all up, and we've got the sum. The sum is 707,827.63, and then we're gonna minus it from the sum of the weight sum, and we're gonna square the weight sum, and that one is 140325516. Okay, sorry, a little bit messy, but that's basically it. That would be following this part of the formula. Okay, so we're going to take all of this, we're going to do this on the calculator. Okay, so we got our calculator, and we are taking 20. Well, actually, let me do the Let me do this first. Okay, hold on. You know something? I took the 60. That would be B52 squared. Okay. Anyway, okay, so I'm gonna take the calculator. Hold on. Where's my calculator? Okay. And I'm going to say take that 15. I'm just gonna do this 15 612 minus the 304704 first, and then I'm gonna times that by 20, and that gives me this number here, negative 5781840. Then I'm going to take, or maybe I'm supposed to do the 20 first. Hold on. 20 times, if I do order of operations, yeah, 15 612, then equals, oh yeah, and then I minus the 304. Sorry, 304,704. Yeah, that's it. Okay, 7536 is going to be the first, what I call the independent variable denominator, right? Because we figured out the x part. Now we're going to look for the dependent variable denominator. Again, we're going to do the same thing with those numbers. We're going to take the 20 and we're going to times it by the answer 70827.63. Find out what that is, and then we're gonna minus it from the 1403256, and we have, try that again. We got 20 times 707,827.63 equals minus 1403256. Oh, 32516. And we've got 124036, right? Let me write that down. 124036.6. Okay, so now we've got our formula. When we put all of that, we've got 7536, and then we have to times it by that answer, which is 124,036.6. Okay, so let's times this by the independent variable, which is 7536. And now we've got a product when we've times both of those together, right? 934739817.6. Okay, so we've got that, and then we have to really get the denominator, right? To get that denominator, we would have to square that number, or we got to get the square root of that number. So to do that, I need a different calculator. Calculator. Okay, and we're going to push that square root number of 9, 3, 4, 7, 3, 9, 8, 1, 7.6 equals 30573.5149697. Let's take a look. We've got, yep, that's exactly it. Okay, 30573. Okay, and then if you look at the equation, to finish it off, you'd have to take 8593, which is the numerator, and we would have to divide it by that denominator that we just came up with, and that is how we're going to get our answer. So just that last final step, 8593 divided by 30573.5, on this one it says 5026. I'm just gonna go with that, 5026. Oh, okay. And so it's saying our R is equal to 0.28106, which is exactly what we have over here, right? Okay, so that's how we're gonna do it on paper. But how we're gonna do it on Excel, even for this complicated thing here, we are going to do it in a much easier way. Let's try this. Okay, for the numerator, again, the formula is the count. So let's take the count. We've got the count is 20. And it says we're going to times the count by, and we're going to put in these brackets, we're going to put what is the total of xy. Where is x? I mean AW, because A independent times dependent. So we're taking the sum of that. Let's close that off. And we're going to minus that from, we're putting another bracket, the sum of x, which is the sum of A, the sum of, take that sum, close that off, times it by the sum of the weight, or the y variable. Oh, shucks. I guess we could put it in the bracket too. Okay, that should be what our numerator is. Our individual denominator, the very first part, for the individual variable, right? Or independent variable, sorry, not individual, independent variable. It says the sum, or the count. We're going to take the count. We are going to times that by, we're going to take the count, we're going to times it by the sum of the age squared, the sum of the age squared, which is here, right? We've got the age squared, take that sum, and then we're going to minus, oh, let's close that off. Actually, it didn't even have it in brackets, so I think we can take it out of brackets. Let's take that out of the bracket. Okay, then it says to minus it from, and this one they put into the brackets, the sum of, it says the sum of the age. Now, the different one, right? You get the sum of the age first, and then they say square it. So we're going to take that sum of the age, and we're going to say make sure you square that. Okay, and then that would be it. We got 7536. Then we're going to take the dependent variable, which would be y, but in our case it's the weight, and we're going to take the count again, which is 20, and then we are going to times that by the weight, every individual weight summed up and squared. So we're taking that total sum, and then we're going to say I want you to minus that from the sum of the weight that is squared, the sum of the weight that's squared. So the sum of the weight and square it. Again, the sum of the weight is this first one, right? The weight summed up, and then we're just gonna take that total, and then we're gonna square it. Where are we? Where are we? Everything's moving all over the place. Okay, okay. Then I close that off. Okay, so we've got the count is here, which is 20, and then we've got the sum of the weight of all the individual weights that were squared, and then we went and we minused it from the sum of all the weights, and then squaring just that sum. And there we go. Okay, then we're going to take those two to follow, right, the denominator. We have to take that number, the first independent variable total, and then take the dependent variable total, which is this whole part of the formula, and it says we have to times it together. Okay, so we're going to take our equal sign, we're going to take the independent variable, we're going to times it by the dependent variable, and we got that total. And last of all, to get the actual denominator, it says we need to get the square root of all of that. So thank goodness for Excel, because it does all the work for us. And we say we want the square root of this number. Good, so we've got that. Now to get the r, right, we have to take the numerator and we have to divide it by the denominator, and we've got the slope, oh, not the slope, but the value of r, which I guess is the regression. And we can see that it's not close to 0.1, and it's not close to, it's not close to -1, and it's not close to +1. So we know that the age is probably not going to be a good factor for how to measure what we're looking for. So we're looking for something where that r is going to be either close to a +1 or close to a -1. This isn't very close at all. So we're going to do that with all the rest. I'm just going to walk through one more. Again, we're going to do the easiest one, which I suggest doing, which is taking the B formula, right, and timesing it by the standard deviation for the independent variable, which in this case it is the height, and then we're going to divide it by the dependent variable, which is again the weight, and that's our r. Okay, doing it the hard way, we are going to go get the numerator by following the formula of getting the count. And I'm not going to keep pointing back at the paper, so I'm just going to do it, and you can look at the paper that you might have. We're going to take the height and the weight, right, all of that times together, and then add it up, the sum of all of that. I'm going to close that off, and we're going to minus that from the sum of the height, and we're going to close. Sorry, I was supposed to put that in brackets. It is B76. B76. I want to make sure I have the right number. Okay. Yeah, let me put that in brackets. Not that one. So after the minus. Okay, put that in a bracket. And then I'm going to say times that with the sum of the weight, which is my dependent variable. Right? And I'm going to close that off. Okay, there's my numerator. To get my denominator, I'm going to start with getting my independent variable denominator. Then I'm going to start with the count again for that. Let's get the count. And I am going to times that by the age squared, which is all the individual ages, the heights, sorry, individual heights that are squared, and then that total. I'm going to take that again, and then I'm going to minus that and put that in a bracket, put this next one in a bracket, because then I'm going to get the sum of all of the heights. I'm going to take the sum of all the heights, actually right there, right, the sum of all the heights. Let me get that again. The sum of all the heights, and then I'm going to square it. Put that little upper thing. Hey, where did it go? Okay, and then there we go. And then I'm going to do that for the dependent variable, and I'm going to again get that count. Get the count. Times that by the weight squared, all of those totaled up, then minus that from the sum of all the weight, and then that one particular one is squared. Okay, close that off. And then I'm going to get the product by timesing both of those numbers together. Okay, and then the denominator, to get the denominator, I need to get the square root of that. So I'm going to type in square root of this number here. What's the square root of that? And then I'm going to come over here for my R. The last thing would be to say, hey, take my numerator and divide it by my denominator. Oh my goodness, I got something that didn't work out right. Let's take a look. Okay, so we've got the B77, which is this here. No, the count. We got B77, and we took and timesed it by this number, which is the weight squared, right? Then we minused it from this number here and squared it. That's correct. We've got that done right. I'm just checking all the things because I want to make sure I get this right. And then this one we have the B77, which is this one here. And we've got that one there, B76, right? Minus this one here. Did I get that total right? And these are L81 times L82, and then I took the square root of that number. That's right. Is there anything else that I'm missing? again. Let me try that again because something went wrong. I have to check my numerator. For some reason these two are coming out different. I will have to take a look. Numerator, we've got this times xy, which is K76, right, minus the sum of B76 and the sum of C76. Really weird. Okay, so I have no idea why they came out different. Let me make sure I've got the formula for this one right. Okay, we've got the B, and we've got times standard deviation for x, standard deviation for this, divided by the standard deviation for that. Yep, that's really weird. I will have to be working with those, but basically the process is correct. I just don't know why the total came out wrong. So anyway, follow these formulas. Like I said, I suggest just doing this simpler one. And now we know why we've been finding out what the standard deviation and all the variance and all that stuff that we need to find out. So that B is going to be really helpful. The standard deviation for both sets, the independent variable and the dependent variable, is going to be helpful for us to just do a simpler way than doing this. I don't think we're ever going to want to do this again and do all of that. But since he taught it in class, I don't know if there's going to be a purpose, but I figure put it in the video. I will figure out what's going on. I think at this point it's just working on doing the simpler one for the rest of this. So you need to, for our homework, we need to find out what the B is, the A is, the R is. Again, we have to look at those charts, those scattergrams, and say, okay, which one do we think is best? And when you look at this R, right, it's getting kind of close to that 0.1. So I'm honestly thinking that height has a probably bigger factor. I haven't done the rest for the chest and all the rest to see what the R is going to be, but whichever one is closer to 1 or -1, that's going to be the one that is definitely going to be a better thing that we're going to be looking at. But anyway, if you have questions, text me, call me. Okay.